Okay, so in the previous class, we seen what is the design procedure for designing a socket and spigot joint. And also after that, we taken up one numerical problem how we can solve the cotter joint, which is used in case of a steam engine, where it is used to connect the piston rod and cross head. Okay, so today we will take up the next one, that is sleeve and cotter joint. So in case of this sleeve and cotter joint, again similar to that socket and spigot joint, so this joint is also capable of carrying only axial load. So that axial load may be the tensile load or compressive load. So the design procedure is same for both tensile as well as compressive load. So whether it is tensile or positive or negative, something like this. P is acting in this direction or in this direction, the design procedure remains same. So now I think I already shown to you a video how this cotter and sleeve and cotter joint is prepared. So in this you have three components. One we call it as sleeve. This one is which one is hatched in case of a pink color. So we'll call it as sleeve. Then you have the rods. Two rods are there, or you can say it is a spigot. So this is one rod and this is another rod. Then you have a cotter. So now to form the joint, or what you have to do is, so for this sleeve there is a rectangular holes are there here, two rectangular holes at the two locations, and that two will take it as a symmetric. That means if I take this is the center, so this side is same as this side. It is symmetric. So in all the senses, in all the dimensions, in all the parameters, as well as in all the everything, so it is symmetric. So that means, so if you design only one half of this one, either this side or this side, that is sufficient. So that means here what we need to do is we need to design three components. Those are sleeve, rod, and then cotter. So these three components we need to derive, we need to design. And what are the various dimensions? You can see first if I take a rod. So first one is D. So this is the D diameter. Then you have a D2. D2 is the outside diameter which is inserted into the sleeve, or you can say D2 is inside diameter of the sleeve. So this is the inside diameter of the sleeve. So D2 we can call it as inside diameter of the sleeve. And D1 is this one, outside diameter of the sleeve. So you have to determine those diameters, D, D1 and D2. So where D is the diameter of the rod, D1 is outside diameter of the sleeve, and D2 is the inside diameter of the sleeve. Then those are the dimensions you need to find for the sleeve in terms of diameters. Then coming to the length of the sleeve. So it is an empirical relation only. We are not going to use any failure criteria to determine the length of the sleeve. So capital L. So don't confuse. Small l is used for the length of the cotter, whereas capital L is used for the length of the sleeve. So it is 8 times D. So that means once you know the diameter of the rod, you can easily calculate using this empirical relation. You can calculate the length of the sleeve. Similarly, the length of the rod. So it is 90. Total distance is 90. So half is going to be 4.5D. So these are also empirical relations only. We are not going to use any failure criteria to derive these things for this one and this one, as well as length of the cotter also. So therefore, in case of cotter, what we need to do is you need to find out B only, that is the mean width, and the thickness of the cotter always will take it as this D2 by 4. So that will follow. Then so this is if you know this distance, then you have to other parameters which we need to calculate is A, C. C is nothing but distance of the hole in the rod from the end. So that is what we will call it as C, and this side portion we will call it as A. So that is distance of the hole in the sleeve from this end. So that we will take it as A. So these parameters we need to find in case of this sleeve and cotter joint. So now we see how we can estimate and what are the failure criteria we need to follow to determine the dimensions for this sleeve and cotter joint. So before that, so again we'll recall the notations what we are going to use in this. So P is the load carried by the rods, whether it may be a tensile load or a compressive load. Then D is the diameter of the rods. Of course, we use all the small letters. D1 is outside diameter of the sleeve, and D2 is diameter of enlarged end of the rod, or you can take this one as a inside diameter of the sleeve also. Both are same. D2, you can take it as diameter of the enlarged end of the rod or inside diameter of the sleeve. So that you can take D2. B is the mean width of the cotter, and T is the thickness of the cotter, and small L is the length of the cotter. So then A is distance of sleeve end from the beginning of the cotter hole. That's what I want to here. This is the distance of, this is the sleeve end from the sleeve end to the cotter hole. So this distance we'll take it as A. Then you have C, that is distance of rod end from its end to the cotter hole. So these are the things what we need to determine. These are the parameters what we need to determine for this sleeve and cotter joint. Other than this, if you require some other data, we'll use empirical relations which are given in the data book itself. We'll use those empirical relations to find the required parameters. So then, to find out all these things, we need to consider various failure criteria. So for those failure criteria, these three are the allowable stresses or permissible stresses in case of this sleeve and cotter joint. So we'll take sigma T is the permissible tensile stress for the rod material, and tau is the permissible shear stress for the cotter material. Sigma C is the permissible crushing stress for the cotter material. See, you can see it here. You have sigma T permissible tensile stress for the rod means. So the fail, you can from this also you can easily understand that the first failure criteria is going to be rod may fail in tension. So then only we are taking permissible tensile stress in the rod. Similarly, you can see permissible shear stress for the cotter material is given means, so the cotter may fail in shear. So therefore, that is one of the failure criteria to find out the dimensions of the cotter. Similarly, permissible crushing stress for the cotter material. So why he has given this one is, so the cotter is subjected to this crushing stresses also. We need to consider that also, right? So with those notations, so what we'll do is we'll go ahead and we'll apply the different failure parameters or failure criteria to determine what are these dimensions. So first in that, first is going to be, first you have to identify what is this diameter of the rod. It is a straightforward. So we need to find out what is the tensile strength of the rod. So then you need to equate the tensile strength to the applied force P. So the rod may fail in tension due to the tensile load P. So then that you need to calculate the tensile strength of the rod. So that is nothing but tensile strength of the rod is nothing but area resisting the tearing of the rod, which is nothing but 5/4 into d square multiplied by sigma T will give you the tearing strength of the rods. So this is the resisting area and this is the allowable or permissible tensile stress. So then this will give you the tearing strength or tensile strength of the rod. So then you need to equate this one to P. So if you equate that one to P, from that you will get the diameter of the rod. D is determined from this equation. So from this equation, the diameter of the rod may be calculated. It is not maybe, it will be, diameter of the rod will be calculated using this relation. So that means first parameter is over. So we calculated D. Then you have D1 and D2. So next one is going to be failure of rod in tension across the weakest section. That is nothing but the slot. If you consider that slot in the rod, so here this is going to be the weakest section. So in this, we know the this D2. D2 is nothing but the inside diameter of the sleeve, or you can say the diameter of the enlarged portion of that rod. So here you can see from the diagram, I'll go back. Here, say this is the dimension. So here you have a slot here. So the dimensions of the slot is, this height is D2. Then maybe you have a width of T or in other direction. So this is B and other direction it is going to be T. So therefore you need to estimate this D2 based on this cotter hole. So that's why we are using those dimensions here. So therefore, this is the area. If you cut the section at that location where you have a slot, so this is going to be the sectional area. So in this sectional area, we need to identify what is D2 and T. So for that, first you need to calculate, since again it is a tensile failure, so then first you need to calculate the area which is resisting the tensile failure. So for that, you have to calculate what is the area of this one. So here you can see the cross section is somewhat like a circular cross section. So in case of circular cross section, we know the area is 5 by 4 d2 square. 5 by 4, if diameter is d2 here, so 5 by 4 into d2 square is going to be the area. But in this entire circular cross section, a rectangular hole is created. So therefore here there is no material. So therefore I need to remove this area where the material is not there because of this rectangular slot to provide or to insert the cotter into the joint. So the area of this one is, so it is a rectangular one. So we know the rectangular area is nothing but height in width into thickness, whatever you can say it here. D2 into T is going to be the area. You need to subtract from this 5 by 4 d square. Then if you multiply this one by sigma T, you will get the tearing strength or tensile strength of the rod in tension across this slot. Then it should be equal to your applied load P. So from this, you need to find out what is the diameter D2. But here the thing is, again, you have only one equation here. So with this, you have two unknown. D2 is unknown to you, even T is also unknown to you. So therefore, we'll use the empirical relation between D2 and T. Your D2 is nothing but 4 times T. Or T is nothing but, instead of using like this, we'll substitute for T. T is nothing but D2 by 4. So now if I substitute that into this, then entire equation will have only one node, that is only D2. So I can solve this equation to find out the D2 value. Once I have a D2 value, we already use the empirical relation between D2 and T, so you can calculate T also. So that's what I found here. Area resisting tearing of the rod across the slot, that is nothing but 5 by 4 d2 square minus d2 into T. Tearing strength of the rod across the slot is nothing but, you need to multiply this one by sigma T. So then you'll get the tearing strength. So that is the tearing strength of the rod across the slot. Then you need to equate this one to the applied load. So from that, you'll get your D2 value. Provided if you assume the relation between D2 and T as T is equal to D2 by 4, right? So then we can calculate or we can compute the diameter D2, which is nothing but the diameter of the enlarged portion of the rod, or we may call it as the inside diameter of the sleeve. So then once you've done this, then what you need to do is immediately you need to check for the crushing stress. Here, once you determine this D2 value, you need to check for the crushing. So that's what we have written here, failure of rod or cotter in crushing. So that means you have to compute what is the crushing stress. For that, first you need to calculate what is the bearing area or crushing area, which is nothing but, so the area which is in contact with the cotter. So the area which is in contact or rubbing action against this hole. I have a hole here in the rod. Okay, let us say here, I'll extend something like this. So then I'm inserting the cotter here. So if I take the other view, this cotter will have a thickness something like this. So here this rod portion is also only, this is the only from this point to this point. This is the area which is in contact. So that means both cotter and this rod extended diameter of the rod is in contact. This is the area what you can consider. These two areas are in contact with each other. So that area is nothing but, we know this diameter is D2 and thickness of the cotter is T. Area is going to be, since it is a rectangular, cotter is a rectangular shape, our area is D2 into T. So then, so that is nothing but our D2 into T multiplied by the sigma C is going to be the crushing strength of the rod or crushing strength of the cotter. So but here we want to check for sigma C. So that is nothing but, you need to take load, that is P divided by D2 into T, will give you the sigma C value. So now whatever sigma C value we got by using this relation, then if the sigma C is less than your sigma C allowable or permissible, then the design is safe. or whatever dimension is chosen for D2 and T, they can withstand, so they won't fail. So now, if that is not the case, suppose your sigma c, whatever you calculated here, P by D2 into T is more than the sigma c, then you need to modify your D2 value. So you cannot take D2 from the equation what you calculated here. Using this equation, you got the D2 value, but that D2 value is not satisfying the criteria for this crushing stress. You need to modify D2 value. Once you modify D2 value, obviously your T value will also change, because your T is equal to D2 by 4. So that means if I change the D2 value, obviously T is also going to change. So now I need to modify this D2 according to the given empirical relations. So once you've done that, so if suppose most of the cases it is within the limits only. If not, you have to use this procedure. Okay, so that's what I shown it here in this slide also. This is the crushing area. Then by equating this, you will get this one. From this equation, the individual crushing stress may be checked. So that means whatever may be the magnitude of the crushing stress due to the given load, we need to verify that whether that is within the allowable limit or not for the dimensions of D2 and T. So once that is done, so we estimated D and D1. Then you need to find out what is the diameter D1 also. D1, D and D2 is over. Now we need to go for D1. So D1 is nothing but, I think it is because it is in shared mode, and now I'm not in a position to show you all these pictures. Actually, if you look at the picture, then it is going to be somewhat easy. Okay, anyway, it is going to be something like this. Okay. Somebody switched on your mic, so just please switch off your mic. So somebody is talking something, so just switch off your mic. Audio, you switch off your audio. Okay, right. So here, this is the cross section. If you plot, so you have a slot, sleeve, something like this. This is the sleeve. Let us say we have a sleeve something like this. Then here I have a hole something like this, cotter hole. So this side also I have a cotter hole something like this. If I take, this is the center portion, so that means it is symmetric. So now, so this is the material what you can take it is. So we calculated already this dimension. This is dimension, we are taking it as D2. Now we need to estimate what is this dimension, outside diameter. That is D1. So now if I take a section here, the section will look like this. So this is what we call it as section across the slot. So here this is the slot portion for the sleeve. So I have taken across the slot, I have taken a section here. If I cut it here, then if I see the cross section is going to be something like this. So now we know these dimensions. So inside diameter is D2, outside diameter is D1, and here I have a rectangular hole. So having this is the total height is D1 already known, and thickness of the cotter, the rectangular hole is going to be thickness of the cotter T. So that's what you can see it here also, it is T. So now to find out the tensile failure of this sleeve across the slot, again what you have to do is you need to estimate what is the tensile strength of the sleeve across the slot. So across the slot, how will you get the tensile strength? So just you need to calculate what is the area resisting the tensile failure multiplied by the allowable tensile stress. That will give you the tensile strength of the sleeve across the slot. So that for that you need to calculate what this is the section what we are considering across the slot. So therefore, for this area, you have to calculate this area. So it looks like something hollow circular cross section with outer diameter D1 and inner diameter D2. So then if that is the case, we know the area is going to be 5 by 4 into D1 square minus D2 square. But here, in addition to that, you have a hole here, rectangular hole, this portion and this portion. So you have to subtract this area. So that is nothing but this rectangular area is nothing but this height into this thickness. Thickness is T. So height what we can take it is this total, in the total distance I have to subtract this much. So then that is going to be the total area. So this distance is D2 and this total distance is D1. Therefore D1 minus D2 is going to be the height of this rectangular slot and T is the thickness. So D2 minus D1 minus D2 into T is going to be the area of the slot. which you need to subtract from the hollow circular projection area. So that's what I showed here. Yes, the area resisting the tearing of the sleeve across the slot is nothing but 5 by 4 d1 square minus d2 square. This is the, if there is no hole, this is the area. But if I have a rectangular hole, so then we need to subtract the area of the rectangular hole, which is nothing but d1 minus d2 into t. Okay, so then once you've done this, then you need to multiply this one by sigma t, so that you will get the tearing strength or tensile strength. Tearing strength of the sleeve across the slot is nothing but this resisting area. This is the resisting area multiplied by sigma t. So now if we equate this resisting strength or tearing strength of the sleeve across the slot to the applied load is P. So then you will get an equation. From that equation you can find out what is the outside diameter of this sleeve. So from this equation you can look at it, this equation here, d2 is known to us, d2 here, t is known to us, only unknown in this is d1. So I can solve this equation to find out what is the dimension for d1. So therefore using this equation the diameter d1 may be calculated. So once you have calculated this, again here also if you want you can check for the crushing, or else we will go for the next one, failure of cotter for shear. So that means, so in those dimensions what we discussed earlier, we calculated d, d1, d2. Now we'll go for b, that is width of the cotter. So here the failure, we know that the cotter is going to fail in shear. So the width of the cotter is determined based on the shear failure of the cotter. So and also we know that the cotter is failed in double shear, it's not in a single shear. So therefore you need to consider what is the area of double shear, then multiplied by the shear stress, allowable shear stress will give you the shearing strength of the cotter. You need to equate that one to the applied load P. So from that you will get the dimension B. So now in this picture you can clearly see that here the cotter is shearing at two locations. So that's why we will call it as double shear. So in two locations here, at this location, it is shearing up. So it is double shear, and at each location you can see the shearing area is going to be this one. So that is here this width is B and this thickness is T. So B into T is going to be the shear area. So at one location, since you have two locations, 2 times B into T is going to be the shearing area multiplied by the allowable shear stress tau will give you the shearing strength of this cotter. So that's what we written here. Since cotter is in double shear, therefore shearing area of the cotter is going to be 2 into B into T. Then the shearing strength of the cotter is nothing but 2BT multiplied by tau. So now if we equate this one to the applied load, which is P, you will get an equation which you can use to solve for this B, which B is nothing but the mean width of the cotter. So we already know T value. So therefore using this equation we can find out what is the B value. So from this equation width of the cotter can be determined. Right? So once you've done that, again failure of the rod in shear. So that means, so to determine the remaining two parameters, you have two more parameters left out, that is C and A. So first we'll calculate the failure of the rod in shear. So why we need to consider failure of the rod in shear? You can go back to the diagram. Here you can see that. So I want to find out what is this dimension C. So how I can estimate this dimension C here? So here you can look at this one. So suppose if force is P is applied to this rod, so what happens is the rod will tend to move in this direction because I am applying a tensile force here. But the cotter is here, so this cotter will resist the motion. So therefore what happens is this portion of this rod end, will subjected to a shear force. So because I am pulling here and this is pushing something like this, so here at this location, wherever you have here the sleeve is there, so here you have a tangential force will act something like this in this direction, P by 2 and P by 2. So this tangential force, what we call it as a tangential force, will create a shear stress here. So that shear stress will cause the failure in this rod end, provided if C is not sufficient length. If C is having sufficient length, then there is no issue. Otherwise, this rod end may fail in shear. And that too, we already seen that kind of failure is also a double shear. So therefore here it is going to be, the area is shear area going to be 2 into C into T. Why I have to use 2 here? Because it is in double shear and this distance is C and thickness of the cutter is only T. So multiplied by the allowable shear stress in the rod will give you the shearing strength of the rod across the slot. It should be equal to your applied force P. So from that you will get your C value. If you solve that equation, you will get C value. So that's what here, 2 into C into D2. D2, not sorry, not T there, it is D2. Vertical height is D2. 2 into C into D2 is going to be the shearing strength of the rod. So if you multiply that one by tau, you will get the shearing strength of the rod end. So you need to equate that one to the applied load. So from that you will get your C value. From this above equation, C may be calculated. So then finally you have A value. So that is also, that A value is determined just by considering the shear failure of sleeve at the sleeve end. Since the socket end is in double shear, okay, it's not socket, here it is sleeve. Even your sleeve is also in double shear, the area resisting the shearing of the sleeve is nothing but, see, we know that at that end the area is going to be this much, d1 minus d2. So you have, the sleeve will have two dimensions, or inside and outside diameter, something like this. You have a sleeve. Okay, if I draw a line here, so this distance what we are taking it as A. So then this D1, the outer diameter is D1 and inner diameter is D2. Which area is going to be, shear area is going to be this area. You have to take, so this area here you have material only here and here. So in between you have a hollow portion here. So therefore this area is nothing but D1 minus D2 into this thickness into this length, that is A. So D1 minus D2 into A, since it is in double shear, you need to multiply that one by 2. So once you've done that, you need to multiply this one by tau, so that you will get the shearing strength of the, it's not socket color, sleeve across the sleeve end. Shearing strength of the sleeve at the sleeve end. So which is nothing but 2 into d1 minus d2 into A into tau. From that you will get, if you equate that one to the applied load, from that you will get the parameter A. So once I know all these parameters, then that's it. So the design is over now. So in case of this, it is somewhat easy. How to, you have a lesser number of dimensions in case of the sleeve, because the socket and there socket is a different. It is not a uniform throughout the length. It is not a uniform section in case of socket. Whereas in case of sleeve, it is throughout. It is uniform. That's why only you have two diameters. Whereas in case of socket, you have D3, D4. Colors are also there. You need to use different criteria for those things also. That means number of dimensions are more in case of socket and spygard joint, whereas in case of sleeve and cotter joint, the number of dimensions are less. Only you have to calculate D, D1, D2, then B, then A and C. So only these parameters you need to calculate. So we already seen what are those parameters also, how we can estimate based on different failure criteria. Okay, now we'll take up one more problem on,
Excuse me, sir.
yes.
Sir, once keep the slide, sir. Failure of rod and shear. Step 6, sir.
Failure of,
Rod and shear, sir.
hmm.
Once keep that slide, sir. Once play that slide.
You want to note it down or you have any doubt
Yes,
in
sir.
that?
I want to note it down, sir. I
Okay.
want to note
Failure
it down.
of rod and shear.
Yes,
Okay.
sir.
Yeah, note it down.
Yes, sir. Thank you, sir.
Okay.
Noted, sir.
Yes. Now note it down this problem, then we'll see the solution also. Design a sleeve and cotter joint to register a tensile load of 60 kilonewtons. All parts of joints are made of same material with the following allowable stresses. Sigma T is 60 MPa, tau is 70 MPa, and sigma C is 120 MPa. That means allowable tensile stress is 60 MPa, allowable shear stress is 70 MPa, and allowable bearing or crushing stress is 125 MPa. And also he mentioned that all the parts are made of same material. Even though he has not mentioned what is the material, but it is same material. So therefore these stresses are same for all the parts. Suppose if you want to use the tensile failure, you have to use sigma T for all the parts as 60 MPa. And if you want to use shear stress failure wherever you are, so you have to use tau is equal to 70 MPa for all the parts. Similarly, the crushing stress also you need to use as 125 MPa for all the parts. Right? So note it down. So if you have a data book with you, just open the data book first. So we'll discuss what are the formulas you have to use. Whatever we discussed right now, you first verify that whether they are available in your data book or not. So then we need to use only those formulas to find out the dimensions here. So open the data book and that chapter number 7 or 8, whatever it may be. So if it is a new edition, you have a 8th one. So open that. So you can go for this one. You have a sleeve and cotter joint figure also there in that. So you can go through that and just see whether those formulas are available to you or not. So in this, he has given the formulas. He has not given any formulas for sleeve and cotter joint. Simply, he has given the figure, but he has not given any formulas. Isn't it? Just want to talk somebody, then only you can understand. Okay, so Sai Krishna,
Yes, sir.
data book ఉన్నామని ఇవ్వగా
అవును సార్ పీడిఎఫ్
ఓపెన్ పీడిఎఫ్ డేటా బుక్ కొన్నా అని చెప్పావు కదా నువ్వు.
ఉంది సార్, తీయాలి సార్. ఇక్కడ ఉంది సార్.
ఎక్కడ ఉంది? దాన్ని లోపల ఎక్కడో పెట్టావా?
అంటే మొన్న ఎగ్జామ్స్ కదా సార్, ఇక్కడ పెట్టాను, తీస్తా సార్. చెప్తా సార్.
తీసి ఓపెన్ చేయి ఒకసారి చూడు. 46 నీ దగ్గర ఉందంటరా? ఏముంది?
పీడిఎఫ్ ఉంది సార్, డేటా బుక్ కొనలేదు.
ఏమయ్యా, ఏమైంది నీకు? డబ్బులు లేవు నీ దగ్గర? మాట్లాడారా
సార్? కొంటాను సార్.
ఎప్పుడు? సెమిస్టర్ అయిపోయినా? సరే ఓపెన్ చేయ, పీడిఎఫ్ ఓపెన్ చేయి, స్లీవ్ అండ్ కాటర్ జాయింట్ ఓపెన్ చేయి. దాంట్లో ఓపెన్ చేసావా?
చేస్తున్నాను.
మరి క్లాస్లో ఉంటే ఓపెన్ చేయడం అవుతుంది అది? $320 నువ్వు మైక్ ఆఫ్ చేయమ్మా.
సార్ చేసేవాను సార్, ఆఫ్ చేసేవాను సార్.
లేదు ఆన్లో ఉంది, ఇప్పుడు ఆఫ్ చేసావు. ఓకే. ఓకే, శివప్రసాద్ దగ్గర డేటా బుక్ లేదు. 319 ఉన్నాడు ఈ క్లాస్లో. 319 ఉందా మా డేటా బుక్ నీ దగ్గర?
పీడిఎఫ్ ఉంది సార్.
ఓపెన్ చేసావా? పోనీ పీడిఎఫ్ అన్నా
చేస్తున్నాను సార్.
ఎంతసేపు ఓపెన్ చేస్తారా?
Yeah.
3:30 ఉందా ఈ క్లాస్లో? గంట 3:30
సార్ ఉన్నా సార్.
ఉందా మా డేటా బుక్ నీ దగ్గర?
పీడిఎఫ్ ఉంది సార్.
ఓపెన్ చేసావా?
సార్ ఓపెన్ చేస్తుంది.
ఓపెన్ చేసావంటరా?
చేసా సార్.
ఉందా దాంట్లో స్లీవ్ అండ్ కాటర్ జాయింట్? రెస్పాండ్ అవ్వగారా 3:30 మాట్లాడితే మైక్ ఆన్ చేస్తా ఆఫ్ చేస్తావు?
కాదు సార్, ఈ పీడిఎఫ్ లోకి వెళ్తుంటే అయిపోతుంది.
సరే ఓపెన్ చేసి చెప్పు, ఉందా లేదా చెప్పు నాకు. LE4 నీ దగ్గర డేటా బుక్ ఉందిరా? ఉన్నాడు LE4 క్లాస్ లో చెప్పాడు. ఓపెన్ చేసే డేటా బుక్
ఉంది సార్, ఓపెన్
ఉందిలే, నీ దగ్గర ఉంది. నా దగ్గరకు వచ్చావు ఎడ చూడాలని డేటా బుక్ తీసుకొని వచ్చావు కదా. ఓపెన్ చేయి, ఇప్పుడు ఓపెన్ చేసి చూడు. కాటర్ జాయింట్ C1 కాటర్ జాయింట్ ఉందా దాంట్లో?
డయాగ్రామ్ ఒకటే ఉంది సార్, ఫార్ములా లేవు సార్.
ఓకే, సో డయాగ్రామ్ ఉంది, ఫార్ములాస్ లేవు. ఇప్పుడు ఏం చేస్తాం మరి దానికి? నో ఐడియా, అంతేనా? సో ఐ కమ్ టు ద రిమైనింగ్ ఆల్సో. PDF ఓపెన్ చేస్తా అంట 30 గడు ఓపెన్ చేశారా?
సార్ ఓపెన్ చేసా సార్.
ఉందా దాంట్లో C1 కాటర్ జాయింట్?
లేదు సార్.
లేదా? మరి దేనికి నీకు ఇంకా PDF? ఇంకొకడెవడు ఇక్కడ 319 ఓపెన్ చేశారు నువ్వు?
ఎస్ సార్.
ఉందా నీ దాంట్లో? లేదా నీ దాంట్లో కూడా
ఉన్నాయి సార్.
ఏముంది?
అంటే 8.5 లో ఉన్నాయి సార్. స్లీవ్ కి కాటర్ జాయింట్ కి.
ఏమన్నా చెప్పు ఒకసారి ఫార్ములాస్ నాకు.
ఓకే సార్. Tangent length of the solid rod, sir.
ఏముంది ఫార్ములా దానికి?
Pi/4 d square into sigma t.
ఓకే, Pi/4 d square into sigma t అంతే ఉందా? దానికి ఇంకా ఏముందా? ఈక్వల్ టు P అనే లేదా?
ఈక్వల్ టు F ఉంది సార్.
మరి లేదంటారా?
అంటే F is equal to P సార్. డయాగ్రామ్ లో
ఓకే,
P ప్లేస్ లో F ఉంది సార్ అక్కడ.
రైట్. సో అలా అన్ని ఉన్నాయి కదా రిలేషన్స్?
ఉన్నాయి సార్.
ఓకే, సో ఓకే, ఇది PDF రూమ్ అంతేనా?
ఎస్ సార్. P is equal to F సార్. అండ్ మన డయాగ్రామ్ లో P లోడ్ P తీసుకోండి.
అది ఓకే, నువ్వు ఉపయోగిస్తుంది PDF. నీ కాడ డేటా బుక్ PDF లో చూస్తున్నావు.
ఎస్ సార్.
ఓకే, సో మేబీ those who have data book na, so for them there are no formulas. డేటా బుక్ ఉపయోగించే వాళ్ళకి ఫార్ములాస్ ఉండవు. ఈవెన్ రేపు ఎగ్జామినేషన్ లో కూడా నీకు డేటా బుక్ వేస్తారు కాబట్టి దాంట్లో ఫార్ములాస్ ఉండవు. నీ PDF దేనికి పనికిరాదు. అప్పుడు నువ్వు ఇప్పుడు ఏదో చూసి ఏదో చేస్తావు, అప్పుడు అక్కడికి వచ్చేందుకు ఉపయోగం ఉండదు. సో దెన్ వాట్ యూ హావ్ టు డూ ఇస్, నేను బిగినింగ్ లోనే చెప్పే వైల్ డిజైనింగ్ వైల్ డిస్కసింగ్ అబౌట్ దిస్ C1 కాటర్ జాయింట్, whatever formulas available in the socket and spygard joint, they are same for this sleeve and cotter joint also. Meeru D1, D2, T, B and A and C, whatever formulas you use, you have to use only same formulas. So here also those who have a data book, who are opening the data book, so that is Sai Krishna, some are LE4, those people who I am saying that those you have a data book with you, what you have to do is you have to use the formulas for the socket and spygard joint formulas, whatever there in the data book, you have to use only those formulas. But only thing is not all the formulas. నీ స్లీవ్ అండ్ కార్టర్ జాయింట్ లో ఏదైతే డైమెన్షన్స్ ఉన్నాయో ఆ డైమెన్షన్స్ సంబంధించిన ఫార్ములాస్ వరకే దాన్ని తీసుకొని సాల్వ్ చేయాలి. అక్కడ ఉన్నాయన్నీ అవసరం లేదు. అక్కడ ఉన్న డైమెన్షన్స్ అన్ని ఈ స్లీవ్ అండ్ కార్టర్ జాయింట్కి ఉండవు. ఉండే డైమెన్షన్స్ ఏంటి? D1, D2, A, C, and B. Only these parameters you need to calculate. So 6 parameters. So now use the data book. Whether you have a PDF, నీ దగ్గర PDF అంటే PDF, ఇంకోటి ఏది ఉంటే అది. So just tell me what are the dimensions of this car. What is the answer for this particular problem. So that you can understand and you can know how to use the data book also. So here this is the problem. So either you can go for your data book, or either it may be hard copy or it may be soft copy, whatever you are using. So now you tell me how to solve this. You need to tell me the solution for this. So that means first what is D, then what is the D1, what is D2, then ABC. So these 6 parameters you need to tell me. Okay, now do that and tell me that answer. So 15 minutes time is there. I think 15 minutes is more than enough to solve this problem. So try to do that. లాస్ట్ క్లాస్ కూడా చాలా మంది చేయలే. లాస్ట్ క్లాస్ ప్రాబ్లం చేయండి అని చెప్తే ఎవడో అప్లోడ్ చేయలేదు. అప్లోడ్ చేసిన ఏదో బూతులు, నేను ఏదో చెప్పింది కాస్త ఏదో రాసినారు, దాన్ని అప్లోడ్ చేశారు. ప్రాబ్లం సాల్వ్ చేయండి అంటే ఎవరు సాల్వ్ చేయట్లా. సో ఇంకో థింగ్ ఏంటంటే, మీ క్లాస్లో 45 మెంబర్స్ లెస్ దాన్ 65% మార్కులు వచ్చినాయి మిడ్లో. మిమ్మల్ని ఏం చేయాలనేది ఆలోచిస్తున్నాను. నెక్స్ట్ ఏం మీ స్పెషల్గా ఏంటి, స్పెషల్ క్లాసులు పెట్టాలా లేకపోతే ఇక్కడ కాలేజీకి రమ్మనాలా అనేది ఆలోచిస్తున్నాను నేను. చూద్దాం, విల్ డిస్కస్ అబౌట్ దట్ ఆల్సో. బిఫోర్ సెకండ్ మిడ్ ఎగ్జామినేషన్ వీ నీడ్ టు డూ దట్ ఆల్సో. సో మీరు ఏమో చేయమంటేనో చేయరు, అందుకని కాలేజీకి రప్పించి ఇక్కడ వచ్చి నా రూల్లో కూర్చోబెట్టేవాళ్ళు మిమ్మల్ని అందరినీ. అప్పుడు కానీ ఆయన చేస్తున్నాం చూడాలి. ఐ విల్ షేర్ దట్ ఆల్సో. సో ఐ థింక్ మీ థర్డ్ ఇయర్ వాళ్ళకి వాట్సాప్ గ్రూప్ ఉందంటారా? థర్డ్ ఇయర్ వాళ్ళందరికీ సెక్షన్ 1కి ప్రశాంత్ ఉండా లైన్లో? రాయల్ మెక్కాడు ఉన్నా లేడా?
ఉన్నా సార్.
రాయల్ మెక్ వాట్సాప్ గ్రూప్ ఉందా?
రాయల్ మెక్ అని కాదు సార్, ఉంది సార్, మన సెక్షన్ 1 ఉంది.
ఉందా వాట్సాప్ గ్రూప్?
ఉంది సార్.
ఆ వాట్సాప్ గ్రూప్ ఒకసారి నాకు పెట్టు, నేను చూస్తాను. నేను ఇన్ఫర్మేషన్ షేర్ చేయాలంటే దాంట్లో షేర్ చేస్తాను.
సార్ నా షేర్ చేయండి సార్, నేను పెడతాను. అంటే అది ఒఫీషియల్ కాదు సార్, అందుకు.
అఫీషియల్ కాదా?
కాదు సార్,
అఫీషియల్గా లేదు అసలు గ్రూప్.
అంటే మా క్లాస్ మెంబర్స్ అందరికి కలిపి సెక్షన్ 1 అని మామూలుగా పెట్టుకున్నాం సార్, అందరం క్యాజువల్, అంటే ఒఫీషియల్ అని పెట్టలేదు.
అవునా, మీరు ఫస్ట్ లో క్లాసులు ఎట్లా జరిగింది మీకు? డైరెక్ట్ ఇట్లా డొమైన్ ద్వారా జరిగినాయా?
అవును సార్.
ఓకే ఓకే రైట్. సో అయితే అట్లాగే ఓకే. సో ఏదో కానీ నాకు షేర్ చేస్తే దాన్ని అఫీషియల్గా ఉంటే బెటర్. అన్అఫీషియల్గా ఎందుకు దాన్ని దాన్ని ఏదో మళ్ళీ ప్రైవేట్ ఏదో చేస్తారు వాళ్ళు. అఫీషియల్ లేదు
సార్, వాడు క్రియేట్ చేసి మిమ్మల్ని యాడ్ చేస్తాం సార్ అఫీషియల్ గా.
ఓకే, వి డూ దట్. ఓకే, ఏదైనా ఇన్ఫర్మేషన్ ఉంటే షేర్ చేద్దాం దాంట్లో. ఓకే, సో ఈ ప్రాబ్లం సాల్వ్ చేయండి అయితే ఇప్పుడు.